Hi there, this is Mr. Schnitzius. In this video, we're going to continue learning about probability in Activity 42. This is Lesson 42-2, Geometric Probability. In this video, we're going to discover ways probability is used in real-life situations and also determine probabilities involving area and involving linear models. So this is on page 621. This problem starts off by saying wildlife biologists study animal populations to determine the possible effects of industrialization. Since it is impractical to attempt to count every animal in a population, samples are taken. The results are extrapolated to the entire population. So Ms. Takeuchi observed 23 wood ducks within a rectangular area along a river that was about 52 feet by 26 feet. So we're going to draw out a picture for that rectangular area. The Cocoa Wildlife Trust wanted to determine if a protected area along a river in the preserve that was 60 feet by 40 feet could support the 36 wood ducks they had purchased. What is the probability that the protected area is sufficient for the 36 ducks? What might affect the survival of these ducks? So part A asks us to find the area of the sample space and then find the number of ducks per square foot. So that area would come out to be 1,352 square feet. The number of ducks per square foot is just the number of ducks divided by the area, so that's about 0.017 ducks per square foot. And then in part B, it says how many ducks might be expected in the larger area. Well, if that larger area is 40 feet by 60 feet, that larger area is 2,400 square feet, using our area formula, times the expected number of ducks per square foot gives us about 41 ducks. Now part C says find the probability that the protected area can support 36 ducks. Well, that is 36 over 41. Remember, 41 was our expected number of ducks in the larger area from part B, or about 88%. So that's a large enough percentage of certainty to consider placing the 36 ducks in this area. And then D is kind of an extra biology question. What might account for a decline in the wood duck population? It could be water pollution or a lack of trees along the river, or maybe hunters. So now in number 2, we're going to look at a geometric area problem. So number 2 says Zelly plans to play the dart game at the county fair. The target is mounted on a dartboard that is 15 inches by 15 inches. The small circle has a radius of 2 inches. The large circle has the same center as the small circle and a radius of 6 inches. If a dart lands in the shaded region, Zelly will win a grand prize. If a dart lands in the outer circular region, Zelly will win a smaller prize. Assume that it is equally likely that Zelly's dartboard will land on any point on the board. Well, let's first label our picture that we have here. So they told us that this inner radius was 2 inches. And they also told us that the radius of the larger circle was 6 inches. So what is the probability that Zelly will win the grand prize? Well, the grand prize comes from landing in this shaded region. So that probability would be the area of the shaded region out of the total area of the square. It's just a part of a whole relationship. So this 4 pi came from doing pi times the radius squared. Pi times 2 squared would be 4 pi. Over the area of the square is 15 squared. This is 15 inches by 15 inches. So that shaded area divided by the area of the entire square, that ratio would be 12.56 divided by 225 would be about 0.056. Her probability of winning the grand prize is about 5.6%. So now we want to find the probability that Zelly will win the smaller prize. Well, in order to win the smaller prize, Zelly would need to land somewhere in this outer ring that we're shading right here. How can we find that probability? That's like finding the area of this blue donut, not including the circle in the middle. Well, we would have to do the entire area for that largest circle, the area of the outer ring, only the blue shaded part, not this part. Well, to get the area of that blue shaded donut, we need to first find the area of the entire circle, which would be pi times 6 squared. That would be 36 pi, but minus the area of the part in the middle that we're taking out, which we saw up in part A was 4 pi. So that would give us 32 pi, or about 100.48 inches squared. And that's still going to be out of the total area of the square. So 100.48 divided by 225 comes out to be about 0.447. Zelly has about a 44.7% chance of winning the smaller prize. So let's look at a linear example. This is number 3. Mr. Torres catches a bus each morning for work. The bus runs every 20 minutes. If he arrives at his bus stop at a random time, what is the probability that he will have to wait 5 minutes or more? Assume the bus stops for an insignificant amount of time. This number line represents elapsed time, and point B is when the next bus will arrive. So part A says if Mr. Torres arrives at the bus stop between point C and B, how long will he have to wait for the next bus? Well, if the next bus shows up here, and he arrives here or later, then at most he would have to wait 5 minutes. If he's closer to point B, then it would be less than 5 minutes. What happens if Mr. Torres arrives at any time between points A and C? Well, then he will have to wait at least 5 minutes, 5 minutes or more. So part C says, what is the probability that Mr. Torres will have to wait 5 minutes or more? Show your work. Well, the probability that he will have to wait 5 minutes or more is represented by any point in this portion of the number line. How many minutes does this portion of the number line represent? Well, that would be 15 minutes out of 20 total minutes, reduces to 3 over 4, which we can write as a percentage as 75%. All right, so we're going to do a couple of check your understanding problems now. Statistical information or data is used to calculate probabilities. The probabilities, in turn, help us to plan for future events such as an earthquake. How might knowing the probability that an earthquake may occur at a particular site be helpful? Well, if we know that we're more likely to experience an earthquake in California than Texas, let's say, then a contractor building a building in California would be more likely to include safeguards against earthquakes than they would in Texas, let's say, or a place where you're not as likely to come up against an earthquake. All right, so this is number 5. Number 5 says Maggie wants to play darts at the school fair. The target is on a square dartboard that is 18 inches on a side. Maggie will score points if her dart lands in any of the concentric circles. She will score 25 points if her dart lands in the bullseye in the center. She will receive 15 points if her dart lands in the gray region, 10 points if her dart lands in the outer ring of the circles, and 0 points if her dart lands outside the circles on the dartboard. Write each probability as a decimal to the nearest 10,000. That's to 4 decimal places and as a percent. So part A says, what is the probability that her dart will hit a bullseye 3 times in a row? Well, that would be the probability that she gets a bullseye and another bullseye and another bullseye. So in order to get that, we need to get the probability that she gets a bullseye once. So that's going to be the area of the green circle divided by the area of the square. Well, let's see. So they gave us the radius for the first circle as 2 inches. So that would be pi times 2 inches squared. But we saw before that that was 4 pi square inches. This time our area for the square is going to be 18 inches squared, which is 324 square inches. So that's 12.56 over 324, which as a decimal comes out to be 0.0388. Now, if that's the probability that she gets a bullseye, well, now we need to get the probability of 3 bullseyes. So the probability of 3 bullseyes would be the probability of getting a bullseye the first time times the probability that she gets a bullseye the second time times the probability that she gets a bullseye the third time. Well, since those throws are independent of each other, that would come to be 0.0388 to the third power, which is going to be quite small. So if we work that out, 0.0388 times 0.0388 times 0.0388, that comes out to be 0.00005. And since they wanted us to write that as a percentage as well, I think, that is 0.005%. That is not very likely. You have to be really good to get 3 bullseyes in a row, right? Okay, so part B says, what is the probability that she will score 30 points in 3 attempts? Well, there's lots of different ways that this can happen. So if we break down the different ways that she can get 30 points, she can score 30 points if she gets 15 points with 2 darts and 0 points with the third dart. Or she can get, so we just basically need to think of all the different ways that she can get 15 points. So if her dart lands in the gray region, then she gets 15 points. Well, let's find the probability of it landing in the gray region. That would be the area of this gray middle ring divided by the square area. So we already calculated the area of the green part in the middle as 4 pi. This radius is 4 inches. So 16 pi, that's pi times 4 squared, minus 4 pi is 12 pi, divided by 324 is 0.1163. It's about 11.63%. So there's another possibility, which is that she gets 10 points. So that would be the area of the outer ring, which is white. So in other words, the area of this part is the outer ring, the band of the circle that's in white. Well, that would be the area of the 6-inch radius circle, which would be 36 pi minus 16 pi is 20 pi. 20 pi divided by 324 is about 0.1939, where the probability of getting 10 points is 19.39%. And then what's the probability that she gets no points? Well, the probability of no points would be the area of the square minus the area of the largest circle divided by the area of the whole square region. So that would be 324, the total area, minus, we don't want her to land anywhere inside this circle, so minus 36 pi. Comes out to be about 0.6509, which is 65.09%. So now we have to think about the different possible ways that she can get 30 points. Well, she can get 30 points by doing 15 points and then 15 points and then 0 points. Or she can get 0 points and then 15 points and then 15 points. Or she can get 15 points and then 0 points and then 15 points. Or she can get 10 points 3 times. Those are all the different ways that she can get exactly 30 points in 3 attempts. Well, the good news about this is if we can find the probability of her getting 2 15s and a 0, then we'll be pretty much set because that'll take care of 3 of these possibilities. So what's the probability she earns 15 points? Well, she can earn 15 points with a probability of 0.1163. That would be the probability of getting 15 times the probability of getting another 15 times the probability of getting 0, which is 0.6509. So let's multiply those together and see what we come up with. 0.1163 times 0.1163 times 0.6509 comes out to be 0.0088. Well, here's what's nice about this. Multiplication, the order doesn't matter, right? So even if we do the probability of 0 times the probability of 15 times the probability of 15, we're still multiplying the same 3 values. So that's going to be the same 0.0088 probability for all 3 of these possibilities. Now we just have to think about the probability of getting 3 10s. Well, that's a probability of 0.1939 for 1 10, but there are going to be 3 different times we want her to get exactly 10. So that probability, 0.1939 to the 3rd power, comes out to be 0.0073. So now we need to find the overall probability that she will score exactly 30 points on 3 attempts. So that's the probability of 15, 15, and 0, plus the probability of 0 and then 15 and 15, plus the probability of 15 and then 0 and then 15, plus the probability of 10 3 times. Now, I listed all 4 of these out here just to emphasize that we need to include all the possibilities. You might find it easier to simply do 3 times 0.0088, and then adding to that 0.0073. So that gives us an overall probability of 0.0337. That is a tricky problem. All right, now we're going to look at one last problem, much easier than the last one, fortunately. Mrs. Ciascio takes a bus every Sunday to visit her mother in the next town. The bus leaves every 15 minutes. If she arrives at the bus stop at a random time, what is the probability that she'll have to wait 10 minutes or more? Well, let's draw out a number line to help us with this problem. So this is the total length of time that she could wait. So she's going to wait 10 minutes or more if she arrives at some point on this part of the number line. I'm rethinking. Teachers are humans too. I'm rethinking this part of the problem. She will have to wait 10 minutes or more if she arrives here to here. Because if she arrives here, let's say at the 6-minute mark since the last bus came, well, then this will just be a 9-minute wait, right? If she arrives here, then this will be an 8-minute wait. But if she arrives here, then this will be an 11-minute wait. So out of the total 15 minutes that she could wait, 5 of those minutes represent her waiting 10 minutes or more. So 5 divided by 15 reduces to 1/3, which reduces to 33 1/3%. So that's it for this lesson on geometric probability. Thank you guys so much for your hard work. Good luck studying for your final exam.